We all know wind power is a huge part of our clean energy future, right? But there's this, well, a hidden challenge that's popping up as the very first generation of wind farms are starting to get old. And the solution? It's all about some seriously cool material science. Let's get into it.
So let me just ask you something. You see those huge, kind of graceful turbines spinning out on the horizon, but have you ever really thought about what happens when they stop? After 20, 25 years of service, what's the end of the line for them?
Well, the answer is kind of shocking, to be honest. Thousands of these absolutely enormous blades get taken down and they just get buried in these giant landfills that people have started calling blade graveyards. It's this massive sustainability problem hiding right in the middle of a green industry.
Okay, so why? Why are we burying them? To really get it, we've got to look at what these things are actually made of. That's really the heart of the whole dilemma.
So most of the blades out there right now are made from this stuff called thermoset composites. The easiest way to think about it is like baking a cake. You mix all your ingredients, you pop it in the oven, and it sets permanently, right? You can't unbake a cake and turn it back into batter. That same idea applies here. It makes the material super strong and super light, which is exactly what you want for a turbine blade. But it also makes it basically impossible to recycle. But the solution is coming from a totally different type of material: thermoplastic composites. Now, if thermosets are like cake, think of thermoplastics as being more like a chocolate bar. You can melt it down, reshape it, let it cool, and do it all over again. The bond isn't permanent, and that is the game changer. And this is where things get really, really cool. Scientists and engineers are creating a whole new generation of materials, basically designing the wind turbines of the future from the ground up.
So what's in this new toolkit? Well, we already talked about those amazing thermoplastics. But they're also working with things like advanced carbon fiber for insane strength. And get this, they're even testing out self-healing polymers, materials that can literally fix themselves. Yeah, we'll circle back to that wild idea in a bit. And this quote just nails it for me. It really puts the scale of this whole thing into perspective. You've got technology that's as advanced as what's in a Formula One car, but you're putting it on something the size of a skyscraper. I mean, just think about that for a second. It's an absolutely incredible feat of engineering. So, what does this new toolkit actually do for us? What are the real-world benefits? It all comes down to three huge advantages, and these are going to completely redefine wind energy.
All right, first up, weight. By using these new materials, the carbon fiber, the thermoplastics, the new blades are way, way lighter than the old ones.
We're talking about 30% lighter. Now, why does that matter so much? Well, if a blade is lighter, you can make it a lot longer. And a longer blade sweeps a bigger circle, catches more wind, and gets way more power out of a single turbine. It's a huge deal. And here's the kicker. At the same time they're getting lighter, they're also getting up to 50% stronger. That strength means we can put turbines in tougher places, like way offshore where the wind is just constantly blasting. They'll last longer, and they can handle pretty much anything you throw at them. But honestly, this is the most important part. These new materials, they're up to 95% recyclable. And just like that, the whole blade graveyard problem we talked about at the beginning, it's solved. This one change closes the loop. It makes wind power a genuinely circular, sustainable energy source. It creates this entirely new life cycle for the blades. And the process itself is just beautiful. It's so simple. You take down the old blade, you shred it up into little pellets, you melt it down, and bam, you have raw material that you can use to make brand new things, maybe even new turbine blades. So you put all that together, lighter, stronger, and recyclable, and what you're seeing is the next generation of wind power. And it's not just a small step, it's a massive leap forward. And this is the so what for all of us. This isn't just some lab experiment. When you build bigger, tougher, and more efficient turbines, it means one thing: more clean energy for less money. It's what makes renewable power something that's truly abundant and available to everybody. So, I'll leave you with this one last thought. Remember those self-healing polymers I mentioned? Just try to imagine a wind turbine blade that when it gets a tiny crack from stress or weather, it just heals itself automatically. That sounds like science fiction, I know, but it's not. It's what scientists are working on right now. Makes you wonder, right? What else could a material like that make possible?